Gad Prathamesh Shivaji.
Present, sir.
Okay. Jyoti.
Present, sir.
Right. Kiran Ligade. Kiran. Lakshmikant. Lakshmikant. Mantesh.
Yes, sir.
Right. Mole Prem.
Present, sir.
Okay. Nagesh. Nagesh. Nandish. Nandish.
Present, sir.
Okay. Pooja Patil. Pooja Patil. Right. Pramod Kumar. Okay. Pramod Kumar.
Yes, sir.
Right.
Yes, sir.
Okay. Praveen. 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 Priyanka. Priyanka. Sandhya. Sandhya. Santosh Pujari. Santosh Pujari. Santosh Sonar. Santosh
Present, sir.
Sonar. Right. Shabaz. Shabaz. Shafia.
Present, sir.
Right. Sridhar. Sridhar. Srishti.
Present, sir.
Okay. Siddharth Varnekar. Siddharth Varnekar. Siddharth Patil. Siddharth Patil. Supriya. Supriya.
Present, sir. Present, sir.
Okay. Vandana. Vandana. Vasant. Vasant. Vedata. Vedata. Yogesh. Yogesh. Mahesh. Mahesh. Dodmani. Balesh. Balesh. Taik Mohammed.
Yes, sir.
Sir, Mahesh, sir.
Mahesh. Okay. Okay. Praveen Rathod.
Sir, Taik Mohammed done.
Yes, I am marked. Praveen Rathod. Praveen Rathod. Abhishek. Abhishek. Aishwarya.
Present, sir.
Okay. Amanullah. Amanullah. Bandolkar Tanay Mohandas. Bandolkar Tanay Mohandas. Right. Bhaurav.
Sir.
Okay. Bhaurav. Bhaurav. Shodhan. Shodhan. Devanar Anil Kumar Shekappa. Devanar Anil Kumar Shekappa. Nand Kumar. Nand Kumar. Pramod Kesti. Pramod Kesti. Rohini.
Present, sir.
Right. Rohit. Rohit. Shashidhar Gaudar. Shashidhar. Sridhar. Sridhar. Snehal. Snehal. Vaishnavi. Vaishnavi. Saish. Saish. Karthik Yam. Karthik Yam. Smita Yam. Smita Yam. Anybody else joined?
Sir, Rohit Ivan.
Rohit, I am marked. Anybody else?
Nandish.
Nandish, I am marked. Anybody else? Anybody else?
Sir, Priyanka.
Priyanka. Okay. Anybody else? Abhishek Palekar. Anybody else? Anybody else? Okay. In the last class, we were discussing about the 8051C data types. And we also discussed few of the operators, correct? Let us continue with 8051C programming. 8051C programming here. These are the different data types that we discussed in the previous class: unsigned character, signed character, unsigned int, signed integer, special bit, yes bit, then special function register, SFR. Discussed about these data types in 8051C language. Then we also discussed about the bitwise operators in 8051C language. These are the different operators in 8051C language, that is AND operator, OR operator, XOR, inverter, that is NOT gate, shift right and shift left. And coming to the programming part, let us write few of the programs today in 8051C language. The first one is write a C program to toggle all the bits of P2 continuously. Take this program. Write a C program to toggle all the bits of P2 continuously. Are you able to see the screen here? Screen is visible?
Yes, sir.
Okay. Note down this program. Write a C program to toggle all the bits of P2 continuously. Write a C program to toggle all the bits of P2 continuously. It is very clear from the statement that we are supposed to write a C program, right? Not assembly program, but a C program. They will clearly mention in the examination. If it is supposed to write assembly program, they will mention as write an assembly program, right? If they expect you to write a C program, then they will clearly mention that write a C program to do so and so, right? You have to read the question, understand, and then write. If it is assembly program, you have to write only the assembly program. For assembly program, if you write C program, you will not get marks. Remember that. And if they ask to write a C program, you write only the C program for that. Instead of C program, if you write the assembly program for that, you will not get marks. Remember. Okay. Now for this program, what they was, write a C program to toggle all the bits of P2 continuously. Now they are mentioning the port P2. Port P2 to toggle all the bits of P2 continuously. What is meant by toggling? Any idea? Toggling. You have learnt in digital. Toggling means
Switching.
switching over from 0 to 1, 1 to 0, right? Continuously. That is called as toggling. 0 to 1 switching or 1 to 0, right? That is called as toggling. Okay. Now here they want us to toggle all the bits of port 2. A port P2 is having 8 bits. Correct. Now we should toggle all the bits of port 2 continuously. Right, and they are not mentioned that we have to use only this particular data in port P2. We can use any random data. We can use any random data stored in port P2. Right? Let us assume the data that is stored in port P2 as 43H. 43H. This is the value stored in port P2. 4 is 0010, then sorry 0100, 01004, then 3 is 0011. 8 bits 01004, 0011, 3. This is in binary. Now we have to toggle all these bits. If we toggle all the bits, then what will be the binary value? The binary value will be, wherever it is 0, it will become 1. Wherever it is 1, it will become 0. 1, 0. Then we have 1, 2, 3, 4 zeros, 4 ones, 1, 2, 3, 4. 2 ones, then 4, 2 zeros. This is the toggling of the value 43H. That is 0, 1, 4 zeros, 1, 1 will become Wherever it is 0, it will become 1. Wherever it is 1, it will become 0. 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0. Now this value is how much? 1, 0, 1, 1. 1, 0, 1, 1 is 11. 11 is B. 10 is A. 11 is B. Right? B. Then we have 1, 1, 0, 0. That is 12. 12 is C. BCH. BCH is the required toggled value. We have to toggle the ports of P2 and get the value in P2 as BCH from 43H. That means we are toggling from the initial value of 43H to the toggled value of BCH. Now, once we have toggled it, what they are asking, this is the algorithm that what I am telling you all now. First step is store the value, right? You have stored the value in P2. And second step is you have toggled the value. Then third step, they are asking to repeat continuously. Repeating the value continuously, right? In C language, we are using this particular statement, this instruction, while of 1, while of 1. Right? This statement means that repeat the operations continuously. While of 1 means the condition is always true. The one whatever is used here inside the while loop, it indicates that the condition is always true. It will never go false. Therefore, while of 1 means the operations are repeated continuously with the usage of while of 1 instruction in the program. Okay, this is how these are the steps or the algorithm for toggling the bits of port P2 continuously. Right? That continuously is achieved by this statement while of 1, repeating continuously. Okay, now let us write a program for that. Hash, we know how to write a program in C language. This 8051C is an extension of C language. 8051C language is an extension of C language with slight modifications. Header file here that is included is not conio.h or stdr.h or math.h, but there is a particular header file that is used for the 8051 microcontroller, that is hash include reg51h, reg51h, reg51.h, reg51.h. This is the header file that is included for the 8051 microcontroller. Now, as we know that when we use the header file in C language as stdio.h, it means all the declarations, right, of the various variables or maybe of different data types are all included in that header file. If you are using the header file as math.h, right, all the mathematical functions are available in that header file. Similarly, here reg51.h header file means all the declarations, all the definitions, defining of the different data types, everything is available in this header file reg51.h. Right? We need not define or declare the variables again, because all the declarations of the variables is done in reg51.h. We'll take up one example, then it will be clear to you how this is done there. Right? I will explain you one example where we are not including the reg51.h header file. Then you will clearly understand it. Okay. This is the first statement, include reg51.h. And second is void main. We are not transferring any values to the main program, so it is empty here. Okay, main function is empty. Then we are using the keyword void. This keyword void, it indicates that there is no return value from the subprogram. We are not at all using the subprogram here, and no value is returned from the subprogram to the main program. Therefore, we are using the keyword void. Suppose say you are written a function, or if you are written a subprogram, right, to do certain things, to add few numbers, to add natural numbers, right? You are returning the value to the main program. Then we have to enter those values here, what all variables we are returning, okay, inside the main statement. But if you are not returning any values, then here we have to use the keyword void. Void means, note that it means that no value is returned from the subprogram to the main program. We are not using the subprogram, and no value is returned from the subprogram to the main program. That is the meaning of using the keyword void before the main function. Then once we have started with the main function, Next is what we are supposed to do here. First one is we have to store the value. We have to store the value P2 is equal to P2 is equal to 0x43. 0x43. This x indicates that it is a hexadecimal value. Right? In assembly language, we write it as 43h, but here we can directly use 0x43. It means that it is a hexadecimal value 43h. To indicate that this x is used, P2 is equal to 0x43. Then we have to write the toggled value. Toggled value is BCH. Here we have toggled it. BCH. P2 is equal to 0x BC. 0x BC. Then close the main program. Close the main program. Okay. Now what we are supposed to do? We are supposed to do this toggling of port P2 continuously. Right? We are supposed to toggle this P2 continuously. To do that continuously, we are using the while loop. It is the while loop that we are using. WHILE, while of 1. While of 1. This is a while loop which repeats the toggling of the instructions that we have written inside the while loop continuously. While of 1, then for while of 1, this is the main function. In the main function, we have written the while loop. Then we are ending the while loop and the main function. First, we are ending the while loop here. Then we are ending the main function. So, 2 opening brackets, 2 closing brackets are necessary here. Okay. This is how, students, the bits of port P2 are toggled by the usage of the port P2 and its toggled value and repeating the toggling continuously using the statement while of 1. Instead of while of 1, we can also sometimes use for loop. The for loop that is used is for semicolon semicolon. This statement can also be used. This also repeats the operations that we want to repeat continuously inside the for loop. For continuous repetition, we can either use while of 1 or for loop, or we can make use of the for loop for semicolon semicolon inside the brackets. Clear here? Is this program understood here? A simple program, small program. First, you have to know the algorithm, what we are supposed to do, the steps, right? And then write those steps in the form of instructions. Okay. The C language, whatever you have studied, it's the same C language with slight changes here and there. Okay. That whenever it comes, I will tell you where there are changes. Okay. Is it understood here, students, this program? This program is clear here to everyone? This program is clear here? Any doubts in this program? Any doubts in this program?
No, sir.
Everybody understood here? Okay, right. Let us move on to the second program. Second one. Write a 8051C program to display the hex values for ASCII characters of 0, 1, A, B on port P1. Note down this program. Write a 8051C program to display the hex values for ASCII characters of 0, 1, A, B on port P1. Did you all note down here? Okay. What they asked, first read the statement. Okay, try to understand it and then develop the logic and accordingly write the algorithm and the instructions, the program. Okay, don't start immediately writing the program as soon as the question is read. Okay, try to understand the question, see what it is, what they have asked. Okay, then understand and then start writing the program. Okay, write a 8051C program. So they are clearly mentioned that it is a C program, 8051C program, to display the hex values for ASCII characters of 01AB on port P1. They want to display the ASCII values of the values 01AB in terms of hex values. Right? For example, the ASCII value of 0 is 30H. ASCII value of 1 is 31H. Similarly, we have ASCII values of A and B. ASCII value of A is 41H. ASCII value of capital B is 42H. Right? These values will be displayed on the port P1. To display the ASCII values of the characters 01AB in terms of hex values on port P1, we have to write a 8051C program. Let us write the program here. Second one. Now, here they are mentioning set of values 0, 1, A and B. Now these set of values are nothing but the what are called as string of characters or array of characters or set of characters. These array of characters can be stored in the form of a string and then they can be accessed by array indexing. Right? These set of characters or array of characters can be stored in the form of a string and then they can be accessed by indexing the array. Array indexing A of 0, A of 1, A of 2. You have used the in C language array, right? Arrays. Right? Similarly, now what we are doing is this string we are storing the given set of values in the form of a string. Let us say x of certain values. Okay, into the bracket means we are storing those values in the array. What are those values? 0, 0, 1, A, B. 0, 1, A, B. This is how we are storing them in the form of string and then we are accessing those values. We are accessing those values by usage of array indexing. Suppose I want to read the value A. Then what I will do? It starts from x of 0, x of 0, x of 1, x of 2, 0, 1, 2, 3. Right? A means x of 2 it is, x of 2. X of 2 means it will read the value A. Now if I want to read the value say 0, then it is 0th value, first value, x of 0, that is equal to 0. If you want to read the last value, that is B, then it is x of 3, that is equal to B. This is how we will be able to access these values by using the array indexing. This is called as indexing the array or array indexing. Index means whatever values we are using inside this bracket, square bracket, that is called as the index. Right? Index is which element we are accessing from that array of characters. Right? Which element we are accessing from that set of characters or string of characters. Right? That is called as the index. Let us write the program now. Always start with the header file if you are writing the C language, 8051C language, that is hash include reg51.h, reg51.h. Then come to the main function, void main does not return any value, there is no subprogram, right? Hence we are using the keyword void. Next comes the declaration. What all we have to declare here? We have to declare the loop index. Right? We have to declare the loop index because we want to read the characters. First I want to read 0, then first character, second character A, third character B. Now if I want to read those characters, I have to use a which loop. Which loop will give me the values here? These values, how can I access these values? Which statement I have to use? Whether I have to use for loop, loop can provide me these values. Yes. For loop can provide me these values or not? Yes. For
Yes,
loop
sir.
provides me the values. Yes.
Yes, sir. It will provide.
Yes. Fine. For loop will provide me the values. I can use the loop.
Okay, sir.
Yes, please. Any problem? Any problem in understanding? Somebody was asking something. Any problem in understanding here? Akshata? Bhakti?
No, sir.
Any problem? Bharti?
No, sir.
Okay. Mantesh?
No, sir, no.
Okay, fine. See here, main function, void main. Then we have to first define the set of characters, that is a string. Okay, here it is what we have to remember is the data types that we have studied. In the previous class, I explained the various data types. Now, if I want to store these characters, right, these are alpha numeric characters or the set of characters, okay, 0, 1, A, B. Then I have to make use of the keyword unsigned char, the first data type, unsigned char, unsigned character X within the empty brackets. Then in the memory location of X of this empty bracket, the various string values are stored, that is 0, 1, A, B, 0, 1, A, B. The set of values or the string of values are stored. These are characters to be displayed. Characters to be displayed. Right? Next statement. This is a comment line I am writing. Double slash means, for double slash means it is a comment line. Okay. It is not an instruction, it is a comment line. Next, once I have defined the unsigned character. Unsigned character means what is the size of the unsigned character? Can anybody recollect? Size of unsigned character data type? What is the size of that? Yes. How many bits it can store, or what is the range of values it can store? Unsigned character.
16 bits, sir.
Unsigned integer is 16 bits. Unsigned character is 8 bit. Remember. Okay. Unsigned character is 8 bit. Unsigned integer is 16 bit. Fine. Therefore, unsigned character has only 4 values are there. So for me, unsigned character is sufficient. I need not go for unsigned integer. When I require unsigned integer, if the value is more than 256, unsigned character means maximum 8 bits, 2 raised to 8, 256 values, 0 to 255 or 256 values, right? If the value is more than 256, the number of values, the count value, if it exceeds, if it is more than 256, then I require unsigned integer data type. Otherwise, unsigned character will provide me the required job. Okay, it will provide me the required thing, right? The unsigned character X is equal to 0, 1, AB characters to be displayed. Then next, which one I have to define? Loop variable, as you are defining in your C language, int I. For the for loop, for I is equal to 0, I less than 10, I plus plus. Then you define integer I, correct? Similarly, here also I have to define the loop variable, unsigned char, unsigned char. Here there is no int data type in 8051C. It is unsigned integer or signed integer. But for me, unsigned character will be sufficient, as the loop index, for me, I require here only 4 values, 0, 1, AB. Therefore, unsigned character will be sufficient. I need not make use of unsigned integer. Right? Unsigned character I. What is I here? I is a counter. I is loop counter or loop index. I is counter used for displaying the characters. Used for displaying displaying the characters. Next, once I defined the unsigned character I, loop index, then I will write the for statement. For I is equal to 0, same thing as you are using C language. For I is equal to 0, I less than 4, because there are only 4 characters, 0 to 3, 0, 1, 2, 3, 4 characters. Therefore, I less than 4, I less than 4, I plus plus, I plus plus. Then what I have to do to these characters, what they have asked, read the statement, program statement. Write a 8051C program to display the hex values for ASCII characters of 01AB on port P1. Right? As I told, ASCII value of 0 is 30 hex, ASCII value of 1 is 31 hex, ASCII value of A is 40 hex, ASCII value of B is 41 hex. Okay, so these ASCII values in terms of hex, they will be displayed on port P1. Like that, we have to write a program. P1 is equal to, I have to use the array indexing. That means I have to assign the value x of I, and I have to store that x of I on port P1, That is, output the character to port P1, output the character to port P1, fine. Next, see, one more statement we are using here. This is the for loop. For I is equal to 0 means x of 0, that is the first value, 0 will be stored on port P1. Then next time I will increment, it will become 1, 0 plus 1, 1. I is equal to I plus 1. Instead of that, we are using I plus plus here. Then I will be 1, x of 1. X of 1 will means 1 here, 1 will be stored on port 1. Then next time I will be 2, x of 2 means A will be stored on port P1. Then I will be 3, then B will be stored on port P1. Like this, the for loop will perform and it will store all the set of values, given set of values, the characters or the string of characters on the port P1. But we have to do it continuously, therefore we are using the for loop. And one more statement we are supposed to write here, it is a while of 1 at the end. I will tell you the reason for this. While of 1, first end it, end the main function. Here we are writing this while of 1. This while of 1 is same as using this in assembly language. Here SJMP here. While of 1 is similar to this statement, unconditional jump statement. Here SJMP here. The reason why we are using this unconditional jump or while statement in C language is, if we do not make use of this while instruction, then in the ROM memory, we are storing all the program instructions are all stored in the ROM memory, right? Some unwanted codes or unrequired codes are stored in the ROM memory. These will be accessed and the program will become indeterminate, right? Program will become indeterminate. That means it will be executed for indeterminate number of times, right? If the codes which are stored, the statement instruction codes that are stored in the ROM memory, they are unrequired ones or non-wanted ones, then even these are executed, the program becomes indeterminate. Therefore, what we are doing is, at the end of the repetition, we are using the while of 1 statement, so that the repetition will be here itself. While of 1 means it is condition is true, again it will jump to while. While of 1 means condition is true, again it will jump to while. The same while statement will be repeated continuously, and this will avoid the indeterminate execution of the program or indeterminate accessing of the codes, the instruction codes of codes that are stored in ROM memory that are unrequired, that are unwanted ones. To avoid this, this statement is used while of 1, or in assembly language we are using here SJMP here. Is it clear here, students? This program is understood here? Yes, please. This program is understood here. Second program. Taik Muhammad.
Yes, sir.
Understood this program? Second one?
Yes, yes.
Okay. Palekar, Abhishek Palekar. Understood? Abhishek? Rohini? Rohini Paule? Is it clear here? Priyanka? Priyanka?
Yes, sir.
Clear
Understood,
here?
sir.
Okay. Right.
Yes, sir.
Fine. So quickly we'll take one more program. Third one. Small program it is. Write a program to toggle, note down this, write a program to toggle the pin P2.4 300 times. Write a program to toggle the pin P2.4 300 times. The first program we have already seen the toggling, right? Here they are asking to toggle only the pin P2.4, not the full port. In the first program that we discussed was toggling of the value on port P2. All the 8 bits of the port P2 we toggled there. But here they are asking to write a C program to toggle the pin P2.4. Only the pin P2.4 we have to toggle. How many times we have to toggle? 300 times. Note the value here. It is 300 times. Okay. I hope everybody noted down this. Write a program to toggle the pin P2.4 300 times. Here they have mentioned the count, that is toggling for how many times? Count is equal to 300. So this 300 is greater than 56. Unsigned character will provide me only 256. Right? Range is 0 to 255, 256 values, unsigned character. Maximum count value is 255. Okay, but as it is more than 256, 300 is more than 256, count value is more here, it is greater than 256, hence I have to use which data type? Anybody?
Unsigned int.
Unsigned int, very good. Unsigned int has to be used because it is more than 256. Therefore, we have to make use of unsigned integer data type. It is of 16 bits. And the range provided by unsigned integer is 0 to 65,535. That is a range provided by the unsigned integer. So instead of unsigned character, I have to make use of unsigned int. Port P2. Port P2.
Sir,
Yes.
sir,
Tell me.
instead of using unsigned and signed int, sir, can we use directly integer and character, sir?
Correct, correct. That's a correct question. Yes, you are right. See here, if we are making use of int, if we write only int, right? By default, it will assume that as signed integer. Getting the point here? And suppose if we write only char, okay? By default, the microcontroller will understand that it is signed character, but not unsigned character. Right? So we have to be very much sure that whenever we are making use of positive values, we have to make use of unsigned keyword. Whether it is unsigned character or unsigned character, if it is integer, if you require more values, more than 256, unsigned integer. Suppose if we do not make use of unsigned integer, then by default, it is going to take it as signed integer. Okay. That becomes, that is the, that appropriate type of data type will not be used. Suitable data type will not be used if we are not using the keyword unsigned here before the int data type or before the char keyword. Got the point here?
Yes, sir.
Okay, fine. Now P2 here is a special function register. P2 is, we know that it is a special function register, SFR. As it is SFR, we have to also define this port P2 pin. What pin they have asked? P2.4. Point they have asked to toggle P2.4. Therefore, we have to make use of the S bit data type, to define the port pin P2.4. It is of single bit P2.4. Therefore, we have to make use of S bit data type as it is a special function register. Okay. Therefore, what we are doing here, hash include hash include reg 51.h then you have to specify which particular port pin it is, right? Therefore, we are defining it as a special function, that is S bit. Okay, because already the bit pins are declared, but we have to know which pin we are making use of. That's why it is necessary to define here which particular bit we are defining. Otherwise, reg51.h will take care of that, this header file. But we should know which pin we are using, right? And which one we want to make use of. For that, we are defining this S bit OPIN pin number is, this is a format, just remember this, P2 cap then 4, P2.4. Okay, S bit OPIN pin, I'm writing it as OPIN. You can use any other terminology also, not a problem. Okay, you can use a DPIN or a GPIN, whatever it is. So S bit OPIN P2.4. That means what it indicates here, it is P2.4. This is how we are supposed to use in C language. We cannot write it as P.4. P2.4 is not supposed to write. Instead of that, P2, this symbol, inverted V symbol, then 4. Okay, this is how we are supposed to use the format. Then this P2.4 is nothing but the D4th bit. It is D4th bit or the 5th bit of port 2. D4th bit of port 2 Fine. Then we are writing the main function void main in the empty brackets. Then start with the opening flower bracket. As the count is more, define that as unsigned integer more than 256, unsigned integer n. Or you can make use of I also here, need not be only n, you can write unsigned integer I. Any of the alphabets you can make use of. Then for I is equal to 0 or n is, we have used here, n equal to 0, n less than 300, n less than 300, n plus plus. This is our for statement, for loop. And as we are using the for loop, what they have asked, they are used to toggle this pin. Which pin it is? 2.4. This is how we are supposed to define that. Now, why we are defining here? The reason is, instead of using P2.4 every time in the program, directly I can make use of this OPIN. Understood here the meaning of this defining of S bit, special bit data type? It is S bit means special bit data type. OPIN is equal to P2.4 means instead of using every time in the program P2.4, I can just make use of this keyword OPIN. That means wherever I am using this keyword OPIN, this term OPIN in the program, that will be replaced by P2.4. That will give us P2.4 every time it comes across OPIN word in the program. Now to toggle it, OPIN pin, first make it 0, Toggling means making 0 to 1 or 1 to 0. Anyways, you can make, first you can store 1 and then 0 or 0 or 1. Anyways, okay. OPIN, that is equal to 1. Then end the for loop, end the for loop. Then before ending the for loop, we can make use of this statement if we want, while of 1, so that it does not store some indeterminate values or it does not execute for the indeterminate number of times. Indeterminate means what? For undefined number of times. Right? It should not repeat. Instead of that, we can comfortably make use of this while statement so that the program will not store some unwanted values. To avoid those storage of unwanted values, we are making use of this while of 1 statement so that it repeats here only, here STMPR, it repeats here itself, and thus it avoids indeterminate storing of the values for the output values for the program. This is how we are executing this program. That is, they have asked to toggle P2.4 continuously for 300 times. Right? This is the way in which we are supposed to write the 8051C programs. Is it understood here, students? How to write the 8051C program? Got the idea? Got the idea here, Shafia?
Yes, sir.
Okay. Jyoti? Jyoti?
Yes, sir.
Got the idea here? How to write the 8051C programs?
Yes, sir. Got it.
Okay. Any questions here? Nandish? Nandish? Gat Pratmesh Shivaji? Any questions? Gat Pratmesh Shivaji? Pooja Patil? Any questions?
No, sir.
Okay. Pramod Kumar? Unshad? Pramod Kumar? Santosh Sonar? Santosh Sonar? Any problem in understanding? Srushti? Srushti? Supriya?
Yes, sir. Understood.
Understood. Okay. Mahesh? Mahesh? Dodmani? Aishwarya? Aishwarya?
Yes, sir.
Is it clear today's programs?
Yes, sir.
Okay. Bandodkar Tanay Mohandas? Bandodkar Tanay Mohandas? Rohit Alwani? Rohit? Okay. In the next class, we'll continue with some more programs. Right? Just go through these programs. Right? We'll be continuing with some more programs in the next class. Okay, that we'll take up in the next class. Okay. Thank you.